Hello friends, waving hand, welcome back to Simple Game. Have you ever noticed something strange? Sometimes the temperature is 30 degrees, but you feel comfortable. And sometimes the same 30 degrees feels terrible downcast face with sweat. Why does this happen? The answer is humidity. And the tool that helps engineers understand this is called the backhand index pointing right psychrometric chart. In this video, I will explain the psychrometric chart step by step in simple English with real HVAC examples. No confusion, no heavy formulas, only clear understanding. So let's start. First of all, what is a psychrometric chart? A psychrometric chart is a graph that shows the properties of moist air. Moist air means normal air plus water vapor. In real life, air is never completely dry. That is why air conditioning, HVAC systems, cooling towers, ventilation systems all depend on this chart. In simple words, backhand index pointing right, the psychrometric chart tells us how temperature, humidity, moisture, and energy of air are connected. Let's understand moist air. Moist air contains dry air, water vapor. Even a small amount of moisture can change comfort, increase cooling load, cause condensation, create corrosion. That is why psychrometrics is so important. Psychrometrics means backhand index pointing right study of air and water vapor together. Now let's understand the chart layout. Think of it like a map of air conditions. The horizontal line is called dry bulb temperature. This is normal temperature, the temperature you see on a thermometer. Example, room temperature 30 degrees Celsius. When temperature increases, we move right on the chart. The vertical line is called humidity ratio. It shows how much moisture is present in the air units. kg of water per kg of dry air, more height equals more moisture. Now look at the curved line on the left side. This is the saturation line. It represents 100% relative humidity at this line. Air cannot hold more moisture, any cooling causes condensation. This is where dew forms, fog forms, water drops appear on cold surfaces. Relative humidity is very important. Relative humidity means backhand index pointing right, how much moisture air contains compared to the maximum it can hold. It is shown by curved lines on the chart. Common values: 30%, 50%, 70%, 100%. Example, 50% RH comfortable, 80% RH sticky, and uncomfortable. This is why air conditioners control humidity, not only temperature. Now let's talk about wet bulb temperature. Wet bulb temperature is measured using a thermometer wrapped with a wet cloth, air flowing over it. Due to evaporation, temperature reduces on the chart. Wet bulb lines are diagonal straight lines. Why is wet bulb temperature important? Because it tells cooling potential of air, performance of cooling towers, effectiveness of evaporative cooling. If humidity is high, evaporation is low, cooling is poor. Now dew point. Dew point temperature means backhand index pointing right, temperature at which air becomes fully saturated and water starts condensing. On the chart, move horizontally left until you touch the saturation line. That temperature is the dew point. High dew point means discomfort, sweating, mold growth, corrosion risk. Now let's talk about energy. Enthalpy means backhand index pointing right, total heat content of moist air. It includes sensible heat, latent heat. On the chart, enthalpy lines are diagonal units, kJ per kg of dry air. HVAC engineers use enthalpy to calculate cooling load, design air handling units, save energy. The comfort zone is very important. Comfort zone is the region where humans feel comfortable. Normally, temperature 22 to 27 degrees Celsius, relative humidity 40 to 60% in this zone. Sweating works properly, no dryness, no stickiness. That is why AC systems aim to keep air in this zone. Now let's see real HVAC processes. Repeat button, sensible heating, only temperature increases. Moisture remains same. On chart, horizontal line to the right, example, electric heater. Snowflake, sensible cooling, only temperature decreases. No moisture removal. On chart, horizontal line to the left. Snowflake, droplet cooling and dehumidification, temperature decreases. Moisture also decreases. On chart, downward left diagonal line. This is the most common air conditioning process. Droplet humidification, moisture increases. On chart, vertical upward movement used in textile industry, paper mills, hospitals. Psychrometric chart is used in HVAC design, cooling towers, pharmaceutical plants, food industries, power plants, data centers. If you understand this chart, You can solve real engineering problems. Remember this: horizontal temperature, vertical moisture, curved left line, saturation, diagonal energy. That's it. The psychrometric chart is not difficult. It is simply a visual tool. Once you understand it, HVAC becomes logical comfort, makes sense, engineering feels easy. If this video helped you, please like the video, thumbs up, subscribe to Simple GAN, share with your friends, comment below. Backhand index pointing right. Which part was confusing earlier? In the next video, we will solve numerical problems using the psychrometric chart. Until then, keep learning, keep engineering. This is Simple GAN Rocket.